Hello and welcome. In this video, we're diving deep into caching strategies, a fundamental aspect of system design. Caching is a crucial technique for improving the performance and scalability of your applications. Today, we'll be exploring some of the most commonly used caching strategies, including cache aside, write through, write behind, and refresh ahead. So, what exactly is caching? Caching is a temporary storage layer that stores frequently accessed data closer to the application for faster retrieval. Instead of always fetching data from the original source like a database, we can store it in a cache. This significantly reduces latency, lowers the load on the database, and improves overall performance. Caching leads to better scalability of any system. Let's begin with the cache-aside strategy. In this approach, the application is responsible for loading data into the cache when needed. The cache acts as a side storage, and the application manages it directly. It's also known as lazy loading, which is one of the important characteristics of cache-aside. Here's how the cache-aside strategy works. First, the application checks the cache for the data it needs. If the data is found in the cache, that's a cache hit, and the data is returned directly to the application. If the data is not in the cache, that's a cache miss. In this case, the application queries the database, stores the result in the cache, and then returns the data to the application. Here is the sample code. A function getUser takes user ID as an argument. It checks if the data is available in the cache for the given user ID. If it is not available, then it will query the database, store the data in the cache, and return it. Next up is the write-through strategy. In this approach, data is written to both the cache and the database simultaneously. The cache remains consistent with the database at all times. This means synchronous writes, strong consistency, higher write latency, and the cache is always up to date. Here's how the write-through strategy works. When the application writes data, it first writes to the cache and then immediately writes to the database. It then confirms that both writes were successful before returning a success message to the application. Here is a sample code. A function called saveUser accepts user ID and data as arguments, sets the data in the cache, saves the data in the database, and returns a success message. Now let's explore the write behind strategy. In this strategy, data is written to the cache immediately. However, the database writes are deferred and happen asynchronously in the background. This leads to asynchronous writes, lower write latency, eventual consistency, and the risk of data loss if the cache fails before the database is updated. In the write behind strategy, when the application writes data, it writes to the cache and immediately returns a success message. A background process then queues the database write and eventually writes the data to the database. Here is a code sample. A function called saveUser accepts user ID and data, sets the data in the cache, adds the data to the queue for asynchronous writing, and returns a success message. Finally, we have the refresh ahead strategy. With this approach, the cache is proactively refreshed before expiration by predicting which data will be needed and updating it in the background. It involves proactive cache refresh, predictive loading, minimal cache misses, and complex implementation. In the refresh ahead strategy, the system monitors cache access patterns, predicts which data will be needed, and refreshes the cache before the data expires. This ensures that fresh data is served on request, and no cache miss is experienced. Here is the code sample. A background refresh job called refresh popular data gets the hotkeys from analytics and refreshes the data in the database for those keys. Now let's compare these strategies across key metrics. The cache-aside strategy offers low write latency, medium read latency, good consistency, and low complexity. The write-through strategy has high write latency, low read latency, excellent consistency, and medium complexity. The write behind strategy provides low write latency, low read latency, fair consistency, and high complexity. Finally, the refresh ahead strategy has medium write latency, low read latency, good consistency, and high complexity. Let's talk about the use cases for each strategy. Use cache aside for read-heavy applications with unpredictable access patterns. Choose write through for applications requiring strong consistency and data durability. Opt for write behind for write-heavy applications where eventual consistency is acceptable. And use refresh ahead for predictable access patterns with strict latency requirements. To summarize, choose a caching strategy based on your application's specific requirements for consistency, latency, and complexity. There is no one-size-fits-all solution. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.